This is Mr. Martin. This is video 1 for Unit 5. We're talking about the unit circle, and we're going to start with it's just a review of angles. So when we're talking about a positive angle, you want to make sure that you draw them counterclockwise. Counterclockwise. Okay, so we're going to be rotating in this direction. All right, opposite of the clock, obviously counterclockwise. So a couple quick examples of an angle. Let's say we wanted to graph 52 degrees. We're always going to start from the positive x-axis. We call this standard form. So when we're graphing this angle, really what's going on here is we have a ray on the positive x-axis, and then this, we would call this the initial side, and then we're going to rotate. Since this is positive, we're going to rotate counterclockwise 52 degrees to get to the terminal side. So 52 is going to be somewhere around here, and then here's our angle, but we always want to mark it to show the direction. So that little ray that goes in between the initial side and the terminal side, that is required. It shows the direction. Again, it's showing counterclockwise, which is our positive direction. So let's take a look at another example. Let's say we wanted to graph 155 degrees. So I know that this is 90 degrees up at the top, and I know this is 180 degrees over there. So 155 has got to be somewhere in the second quadrant, so somewhere around here. Here's my terminal side. Make sure you draw your initial side and then show that it's going counterclockwise. Okay, and then sometimes you can label that part with 155 degrees. Similarly over here, we could have written 52 degrees. Okay, so those are positive angles. Then when we talk about negative angles, these are drawn clockwise. So it seems a little bit backwards based on what we're used to, because we're used to looking at the clock, and since that's so normal for us, we would think that the clockwise would be positive, but it's actually the opposite way. Counterclockwise is positive. And so now we're rotating this way, same way as the clock. So this is our positive direction, and this is our negative direction. Again, let's take a look at a couple examples. Let's say we have negative 100 degrees. Now, it's important to realize we're not going to rotate to 100 degrees. We need to rotate an amount of 100 degrees from the positive x-axis. So here's my positive x-axis, here's my initial side, and now I know if I'm rotating down this way, once I get to there, that would have been 90 degrees in the negative direction. This would be negative 90. So I just need to go another 10 degrees like this, and that would be negative 100 degrees. Again, make sure you indicate the direction of rotation with that curved arrow that goes in between the initial side and the terminal side. And let's take a look at one more example. Let's say we have 400 degrees negative. So I'm going to start with positive 400 degrees. We'll graph that one as well. So positive 400 degrees, we're going to go all the way around. So that would be 360 and then another 40 degrees. So somewhere around here. Here's my initial side. So notice how I show this going all the way around. So I'm going to go all the way around, and I kind of make a spiral, and then I go to there. So that would be positive 400. Now, negative 400 is going to go this same amount, but I'm going to start rotating in a clockwise position. Now, an easier way to think about this is if you can find where the positive angle is, the negative angle simply reflects over the x-axis. So here's my initial side. Since positive 400 landed in the first quadrant, negative 400 is going to land in the fourth quadrant. And again, we can show that we're rotating there by doing, it's going to get a little messy, but we'll go with it, negative direction all the way to there. So that would be negative 400 degrees. And I'll talk more about graphing negative angles later in the video as well. So as always, feel free to pause, rewind as needed, write down your questions, and make sure you ask me. So what we want to do for these is we want to sketch each angle on the axes given. So why don't you go ahead and pause the video, and then when you restart the video, these solutions will be up. And again, if you have any questions, you can always ask me about that later. So go ahead and pause now, and when you restart the video, the answers here will be there so you can check. Okay, so here are the solutions for the first two. We've got 45 degrees positive, so we're rotating counterclockwise. We're in the first quadrant. And then here's negative 210 degrees. Again, if you want to think about rotating positive 210, once I go halfway around, that's 180, so I'd need to go another 30, so I'd be somewhere over here. And then you just reflect that over the x-axis to get where our final angle is and rotate clockwise to get there. So now we have these angles, and these angles are in radians. So whenever I have radians, sometimes what I like to do is I like to mark my quadrant angles. So my quadrant angles are here at 0, 90, 180, 270, and then back to 360 if I'm going all the way around. But I'm going to mark them in terms of the denominator of my radian fraction. So in this case, I have fourths. So I know that halfway around the circle is pi. So this is pi. And in terms of fourths, that would be 4 pi over 4. Alright, so I would start at 0, and then I would go halfway around to pi, which would be 4 pi over 4. And then if I kept going all the way around, this would be 2 pi. But in terms of fourths, it would be 8 pi over 4. Notice 8 over 4 reduces to 2, so that's 2 pi. So now I've got my 180 is 4 pi over 4. My 360 is 8 pi over 4. And then I know my 90 is halfway in between, so if this is 4 pi over 4, this would have to be 2 pi over 4. And again, I'm labeling my quadrant angles in terms of fourths. And then I need to mark my 270. A little trick here is that if you add up the 90 and the 180, that's going to give you the 270. So 2 pi over 4 plus 4 pi over 4 is 6 pi over 4. So once you get the hang of labeling your quadrant angles like this, it really is pretty quick and simple, and it'll keep you from making a lot of mistakes. And once we have this, we can go ahead and we can mark 5 pi over 4. So I'm going to start here with my initial side on the positive x-axis. I'm going to rotate counterclockwise, which is our positive direction. Here's 4 pi over 4, here's 6 pi over 4. So 5 pi over 4 has to be right in the middle. We indicate direction and label the angle 5 pi over 4. Alright, moving on to the next one. In this case, we have pi over 6's. So I know I'm starting at 0, and then I'm going to come over here to pi. So in terms of sixths, it's going to be 6 pi over 6. If that's halfway around, all the way around would be twice that, so 12 pi over 6. Then I can mark my 90 and my 270. It's 6 pi over 6 halfway around. So halfway to there, or a quarter way, it would be 3 pi over 6. 90 plus 180 is going to give me the 270, so 3 and 6 is 9. This is going to be 9 pi over 6. Okay, and this is where that trick of reflecting over the x-axis to get the negative might come in handy. If it was positive 7 pi over 6, I can see it would be right about here. Because 6 pi over 6 is 180, so I have to be 1 more pi over 6 past 180. So now, all I need to do, I'm going to draw my initial side, and then I'm going to flip this over the x-axis to over there, That's a little bit off. Let's try that again. So just reflect that over the x-axis. Make sure I notate that I'm rotating in a negative direction, and then label my negative 7 pi over 6. Okay? Alright, so that's it for this video. The next video we'll start with converting between radians and degrees and radians. And again, make sure that you ask me any questions you have on this. This is really important material that we're going to keep using for quite a bit. So we'll see you in the next video.